Hi, everyone, and welcome to week 7. I think I'm all set here. So welcome to week 7 of Violent Python. Let me just make sure you guys can hear me and see my screen, and we'll get started. I don't have a lot to cover tonight, but it's kind of an interesting kind of transition into our into the violent part of the course. You got to have some more fundamentals before we can do anything in that area. Can you guys hear me and see my screen okay? Great. Thanks, Elizabeth. Appreciate it. Okay, so going through week 7, I'm certainly going to go over the web extraction thing. I'll do that first. I'm actually going to do that from within the VLE just so you can kind of see how it works within that environment as well. So let me jump into that, and then we'll come back and we'll talk a little bit about socket programming and how all that works. Sorry, I've got a lot of briefings lined up for tonight. So okay. You guys can still see my screen, right? Because I'm in the VLE.
Yeah.
Good. So I provided a couple of days ago a sample script to kind of show you this process of doing the processing of the website via using recursion. And I'm going to go through that particular version here, but in this particular case, I'm going to pull all the information that I had requested. So we're going to step into the recursive suite. So basically, there's kind of 3 pieces of information I wanted to provide. What is the base URL of the website that we're going to go after? What's the base domain? And then what it must include so we don't evolve outside of the domain when we're actually doing our recursive scan, of that. So let me set a breakpoint here and just say go, and I'll step through the recursive piece here. So just from a background point of view, what recursion is the ability for a function to be called to call itself. And in many cases, this is pretty useful because especially like in this case, when I'm actually trying to traverse a website, I want to be able to, when I find something, call the function again and find the next thing and kind of move through the process from that perspective. So that's what we're going to do here. So in this particular case, I'm going to basically set those initial variables that I have, and I'm going to set the page links. I'm going to add that at the top. I created a list of the page links. It's actually a set that I created so I can keep track of all the links that we find so we can make sure that we can go to all of those. So I basically added that base URL to the list because that's one of the ones we're going to go to right at the first. So it's the first call that we're going to make to the recursive function. So what I'm going to do is the recursive function can be stepped into. So I'm going to go ahead and step into that. I can just hit the F7 key, but I want to kind of show you how that works. So in this case, I'm going to make sure that the base is in the new URL. If it's not, then we're done. But in this particular case, I'm going to go get a request from that first URL, which is the home page, right? It's the base page that we're going to process. Just like we did in stepping through some of the stuff the other day, we're basically just going to go out and get the contents of that particular page. And now what we're going to do is I'm going to use Beautiful Soup to process that page because I want Beautiful Soup to parse the HTML, the hypertext markup language that's part of the page, because now we have the page text, right, that we can look at. But I'm going to basically process that. One of the things that I can get from Soup is the title of the page, which is one of the things that we wanted to be able to provide. So I'm going to go ahead and print that out. That's one of the things that we wanted. So the title of this page was Dashboard. So I'm going to basically check to see if there were links. So I'm going to call Soup again, and I'm going to say find all the link identifier. So I know what links are on this particular page. Then I'm going to process each one of those links. So in this case, the first link we're going to process is the login link. Okay. And so that's going to be our new link that we're going to get. And if it's not a new link, we're going to continue, but it is. Now we have to do something kind of special here because sometimes the links within a web page are relative and not specific. So in other words, kind of like a relative path in a file, this is going to be either relative to the base or it's going to be new. But in this case, it is in fact relative. So the actual link is /login that we want to go to. So we actually have to create a real link if we want to be able to do that. So what I'm going to say is, well, the new link is going to be the base that we passed in, remember, which is https castle.website. So now I have a new link that is the complete link that I want to go to the first time that I actually process this. So now what I'm going to do is I'm going to use that new link, and if it's not in the page links, I can actually go ahead and process it. So the first thing I'm going to do within that particular page is I'm going to go find all the image tags. And then for each one of those image tags, in the previous example, I showed you how to extract the actual image. And so that's what I'm going to do here. I'm going to get the URL of the image, and I'm going to print a little message that, hey, I'm processing this image. So I've got the name of the image now. And again, in this particular case, if the beginning of the image isn't HTTP colon, I'm going to have to add the base again. So in this case, the image URL that I got originally wasn't the full link. It was only a portion of it. So I have to basically prepend the HTTPS Castle website to that particular link. And so now I can actually get the image base name, from that. There's a method within the OS path library that allows me to separate out a string and actually get the base name of that. And it's logo-7.png. So based on that, I can save that path. And now what I can do is I can make another request to requests, just like I showed you in one of the examples, to get the contents of that particular URL. And once I do, I can get the image content, and then I can actually write it out to the file. And I can print out the fact that I saved that, and this is where I saved that information. That was it was /content images logo7png, and I saved it to /images /logo7png on my local system. So I'm basically going to save that file. It's going to do that for each of the images that were in this particular HTTP, this particular web page, and there were several. So it's going to process all of those within the page. So remember, we're on that first page and we're processing all the contents of that particular page within this recursive call. So I'm going to set a breakpoint down here so we don't have to go through all of that. And when I do, it's going to have processed all of the images that were on that page. So we now have the title, we have the images, and we have where we saved them. So now I can actually add to page links that new link that I created, right? And what I can do now is I can call the function again from within the function. So remember, the name of this function is recurse URL. What do I have to call that function with? The new URL that I want to process. I have to basically call it with the base and what is the definition of local, which is anything that has CASL in it. So if it's not in CASL, we want to ignore it. So in this case, I'm going to call this again. So I'm going to say F7 one more time here. I won't go through all the pages. And now we're here. So now the new URL we're going to process is Castle website login. That's the page we're going to process now. Again, we passed in the base. We passed in the local, just like we did when we called it from main, but we're calling it here. So we have to provide all that same information. If you don't, then it will fail, right? So now we can process the login page. So I won't go through all of that again, so you can kind of see how this actually works. Once we have processed all of the pages of the website and all of the links and all of the images, we will be done. And let me clear all my breakpoints here so we don't have it, and I can just say go. Debug. Actually, you know what? Let me set a breakpoint back in main so we don't lose control here. So this is where we called the recurse URL that's going to continue to call itself to process all the pages. And then we're going to print out scanning complete. So I'm going to just say go. This is going to take a little bit of doing because it's got to process all of those pages and pull out all of the content, including the contents of the image. So now it did that. It's going to print all the unique URLs discovered. So that was one of the things we wanted to print out because we saved those. So these were all the URLs that were part of that CISL website. So we basically have scraped that website with all of the information. In addition to scraping that content, if I go to my persistent drive on D and I go to 473 in week 6, I had created this directory called images. And so in the directory called images are all of the images that I extracted from that particular web page. And they're all laid out here. So everything that was on those pages, and only one of them, because remember, these images could exist in multiple pages. So we want to only basically get them, one time. So that's what we're seeing. So we were able to get all of the links, and we also were able to get all of the titles of the pages that we process. You can kind of see in between here, we got the title of this dashboard, then it was login, then we went to dashboard again, then we went to login again, was the name of another page that had the same title, then services, then news, then contact, and then we were done. So those are the pages that we processed within, those are the titles of the pages that we processed within the CISL website. And these were all of the links that we discovered, along the way. And notice there's duplicates because some of the pages pointed back to themselves. So when you think about a web page structure, the pages can point back to other pages. So you can have duplicates here in the links that we have, but the recursive algorithm basically handles that. So we make sure that we're only going to go out and process a page that we haven't processed yet because we've saved those. The pages that we're processing, we've saved those so we can check to make sure that we haven't already been there. So if it's not a new link, we're going to continue. So that's how we do that. So the from that perspective. Okay, so that's how I processed it. Like I said, how you approach this might have been different. In other words, you could have kept lists of things and sets of things and gone through this more programmatically without using the recursion, but I will post this script for you. So you can actually step through it on your own to kind of get a feel for how to use this very powerful concept within most programming languages, not just Python. All can perform recursion in order to be able to call itself. That's all recursion is. It's a function that has a call inside the function to itself. And I know that may seem, difficult to grasp, but it's a very powerful concept, especially when you're doing something like this. Okay, before I jump into this week, any questions on the solution to week 6? And again, I will post that for you tomorrow, along with this video, which I am recording, which is good. And you can kind of watch it again if you had any questions about that. Okay, I'm going to exit out of the VLE carefully. So I don't exit out of the you guys can still see my screen, right? Always when I exit out of the VLE, I'm worried that I'm going to lose the Zoom link, but I don't think I did. Cool, thanks, Jim. Okay, so back to the correct briefing. So tonight we're going to talk a little about real short briefing and a couple little demos on network sockets. In order to be able to do some basic things with network sockets, we're going to create a simple server and a simple client. And I'm giving you those starter scripts so you can complete this week's assignment. So let's talk about what those are. So I can actually bring this up. So there's a really good website out there, Real Python sockets. There's that has some really good information. It's just another reference for you guys to go take a look at if you want to learn a little bit more about sockets. There's also some good information in our textbook, on that. So you should be reading that section as well to kind of get a firm grasp on the on the concept of network sockets. They're used in all communications that we do within the internet or intranet or the cloud. Sockets are what's used to have two computers communicate with each other, or even the same computer communicating with itself. So a network socket is an endpoint that provides for communication between two running programs, or the simplest form, from the same program. We can have it communicate. So some programs actually use this concept to communicate information, as a process within the program, but more traditionally it's used for two computers to be able to connect over a particular port. So each of the computers would have an IP address, and they would decide on a port where they're going to communicate and exchange information. And we're going to do some really basic things this week with sockets in order to get a feel for how they work and how we can use Python in order to be able to program and create sockets. And like I said, an even simpler example is, which I'm going to show you in a minute, we can send a message from one program and receive the message on another program over a socket that we have defined. And I'm going to show you how to do that next in the simple demonstration. So you have a baseline, again, a starter script for the server and the client in order to work from. So again, in order to do this, we need to write two simple scripts. And I'm giving those to you, the starter server script and the starter client script. Both are provided for you in D2L for you to experiment with. And I highly recommend, as always, to those starter scripts that I'm providing you with is where you should start, so you can kind of get a feel for how this works. Using the starter server script and client script to repeat this is kind of your hands-on exercise. I'm going to demonstrate how this works, but there's a couple things that you need to know. Number one, if I'm going to communicate from the client to the server over a socket like this, the server has to be running first. So in other words, I have to make sure the server is running so the client can make a connection to the server. Kind of makes sense, right? The second thing is the server needs to be running as root or administrator in order to be able to receive information. So you got to make sure that you have the server running, in an admin window, or as I'm going to show you, you can bring up two Wing IDE environments in order to be able to do that. So with that, let me, I have two Wing IDE environments running here because you can do that, just so you know. So the one on the left, I have started as admin. So the way you do that within Python, you just go to your Wing IDE, and then you would basically go to whatever version you're doing. You would right click on that, and then you could run it as administrator. And that's what you need to do on the server side. So we've got the server here, and let's kind of walk through the basic structure of the server. So the server is going to be able to set up a socket on the server in order to be able to receive or get a connection from a client. So the first thing it's going to do is it's going to get its IP address. And within Python, we're going to use the standard library socket. And again, the nice thing about using the standard libraries within Python, because they work on all platforms. I'm sure you've heard me say that enough. But if you're running this on Windows, Mac, Linux, whatever, the socket library is available to you. So what I'm going to do is I'm going to create a socket first, and you do that by making this call to socket that gives you a socket. And then I'm going to define my host address. So I want to get my local host address. That's going to be the IP address of my computer. And I'm going to specify a local port. So then I'm going to bind that IP address, my local host, with the local port. So I'm going to basically bind those together so that I can actually use them. So I'm going to make another call to the server socket that I created. So up here, I created a server socket by calling that function. Hang on a second, let me close my emails here. Always a good thing to do. So, and then once I've made that binding, so I've created this socket, I'm going to use the socket to bind my IP address with that local port. And then what I'm going to do is I'm going to use that server socket to say, I want to listen for a connection on that particular port. And then I'm going to sit here and wait. Now, what this is called, in this particular case, we're going to listen. And down here, I'm going to wait for a connection. So this is what we call in programming a synchronous call, meaning we will not leave this point until we get a connection. It's just going to sit there forever until we actually get a connection from the client. Once I get a connection from the client, I get some basic information from the client. That information is the connection and who the client is. So I can print out that information. And then I'm going to basically receive data from the client. I'm going to receive a small amount of information and I'm going to print it out. If what I get back from the client in the message that they send is exit, okay, then I'm going to exit and terminate my server. Otherwise, I'm going to just basically print out whatever the client sent. So on the client side, the setup is pretty much the same. I'm again going to bring in the socket library. So these kind of parallel each other, at least at the top, where I'm going to get the client socket, the local host, and I'm going to print out a little message here. And then the client is going to try to connect to the local host on the specified port. And they have to be the same, right? In this particular case, they're the same because they're both running on my machine. So the IP address is going to be same. And we've defined the port number to also be the same. So they're going to be able to connect. So then what I'm going to do is I'm going to make a connection. I haven't done anything yet except connect it. And then what I'm going to do is I'm going to prompt the user to type in a message. And then since I have a client socket now, once I make that connect, I can use the client socket to send the message bytes that I'm going to create. And that's all I'm going to do. So let's go ahead and run the server here. I don't think I started this yet. So we'll run the server and we'll see what the server does. And basically it just comes here as I promised. It's waiting for a request. That's where we are. And we're sitting here waiting for the client to do something. So the reason that I have the two Wing IDE environments here is you can then debug if you want to. In other words, you can set breakpoints in each one of these and basically step through both sides. So it's a really cool to be able to do that. So what I'll do here is I'm going to set a breakpoint right here in the client. Hey, just before I send the message to the server, I want to set a breakpoint so we can step through that. So on the client side now, I'm going to go ahead and I'll restart the client. And I'm just going to say go. Oh, crap. Of course, it was on the wrong debug stop. Hang on a second. I got multiple scripts on this one. I had the wrong one selected when I typed run here. What is wrong with my computer? Here we go. This is the starter client. Okay. There was another script that hadn't been stopped before, so I had to rerun it. So I'm going to say start go. So now it's going to run the client and it's going to stop at my breakpoint. So a couple of things happened on the server side already. So remember what I had mentioned, when I get that accepted connection, I get a couple pieces of information. I get the connection and then I get the client. So in this case, I said connection received from client. And what is the connection and what's the client? So it's going to basically give me information about the socket and the type and the protocol and the IP address and the port that's involved, with this. So I get a lot of information back from that simple connection regarding the connection and the client that I'm connecting to. Okay. So we've done that so far, which is good. Now remember, the server's still running. I didn't stop the server because now what the server is here, he is now waiting for data to be received. So we got the connection, we printed out the connection, and now I'm at another one of those synchronous calls where I've called the connection and said I want to receive on up to 2048 bytes. So I'm not moving on the server. It's just stopped there waiting for the client to do something. So on the client side, I've set a breakpoint here, but I'm waiting for the user to enter an input. So let's type in some data down here in the window. We'll call this test1 and hit enter. So now what I'm going to do is I'm going to try to send that message test1 to the server, and it will receive it here. We'll set a breakpoint here after we print out that information. So now I'm going to come back over here and say F6 to execute that. And you notice I printed out test1. So I was able to send the test message over to the server. I printed it out. Now I'm going to check to make sure it's not exit. If it's exit, then I'm going to break and leave this loop. Otherwise, I'm going to stay in this while loop forever. So in this case, obviously, it's not exit. Make sure I'm in this bright window. It's not exit. Come back. And now we're going to wait for another message. On the client side, I can get another message. We'll call this one test2. And we'll send that. And we'll print that out on this side. We got test2. It's not exit. So we wait again. So this time I'll actually type in exit. I want to basically say I'm done communicating with you, server. So I'm going to hit enter. Come down. So I can step through both sides of this, which is really cool. So now I'm going to actually come back over to the server with my cursor over here and say F6. It printed out the string exit. This time it's going to say, yes, exit is in that. So I'm going to say print terminated by server. I'm going to break out of my while loop and we're done. So now I have this message and the server is stopped. You notice that the server is no longer running. The client is still running, but it can't connect to anything right now because there's no server ready to receive the data. So those are two scripts. Now, you don't have to run these two scripts within the integrated development environment. You could bring these up into two windows, you know, from a command line perspective, and you could run one here and bring up another one, run the other one. So you could put the server in one command prompt, and you could put the client in another command prompt, and you could do them there outside of the debugger, just so you know, if you wanted to do that. Okay. Any questions on that? So basically, one of the hands-on exercises that I want you to kind of consider is using the starter scripts. You can repeat the experiment and, you know, obviously make sure you can duplicate the results that I'm showing you. And you can do that within the VLE or on your own machine. And the challenge would be, if you find this kind of easy, you know, read the contents of a text file on the client side and send the entire file as a message. Not the file name, the contents of the file as a message to the server, and see if the server can print that out. So just kind of another challenge. And then next, what we can do is you could modify this server, and this is part of your assignment this week. You could modify the server to reply to the client with the message that it received the client message. And then you could modify the client to receive the response or the reply from the server. So you can have this kind of echo concept going on. So you can kind of change those starter scripts to simple server echo and simple client echo. And now you can actually have them send a message from the client and have the server repeat it back. So for this week's assignment, you're going to take that just a little bit farther than that. And you bring up the week 7. There are 2 assignments. Obviously, you're going to create this TCP server, kind of like what I did. And the server will receive the message and create an MD5 hash of the message and respond to the client with the MD5 digest that was generated. And the server will continue to operate until determined by the user, kind of what I just showed you here. Why are these not enabled yet? Sorry. That was a video. Turn this on and turn this on. And then for the client, after reviewing and kind of looking at chapter 2, create a standalone Python script that will act as a TCP client. You can use the base script that I provided you as an example. And then the client will send 10 messages to the servers with different content and receive the Hex Digest response from the server, and then obviously print that out. And then you're going to basically provide your Python script in the log of all the messages and responses within that. So let me enable this one. So now you have the assignment for week 7, which is to build upon the 2 starter scripts that I've provided in this way and basically submit those 2 new scripts that you're going to create, which are going to basically add on to the starter scripts that I've provided for you. And then you can do those practice examples that I suggested in the briefing, because that'll give you kind of a hands-on, this is where I'm going with this when you try to solve the actual assignment. And then there's a quiz. Any questions? And again, we're going to do more with networking next week and creating a sniffer that can sniff all network traffic and display the contents of that from a passive perspective. But this is kind of the first foray in being able to have 2 processes communicate with each other over a socket using Python in order to be able to be the mechanism for creating the server and also creating the client that can communicate and basically create this bidirectional communication between the server and the client, actually from the client to the server and the server back to the client. Any questions? You guys still there?
Yes.
Just marveling at how back in the day with C or something like that, you had all kinds of nasty constructs to deal with. Now you've got 3 lines of code and you're good.
Yep.
Amazing.
That is the beauty of working with Python, because the libraries have been constructed in a way that makes this kind of ability to be able to get work done without having to think about things like complex data structures in order to be able to do it. The libraries handle that. And again, just to reiterate the point from earlier, these standard Python libraries run on every version of Python. So if you're doing this on a Mac or a Windows or Linux machine, Raspberry Pi, whatever, these scripts are going to create will actually work on each one of those. So you don't have to do something different on a Mac than on a PC, than on a Linux machine or Raspberry Pi or Arduino, whatever you're using. This code will run. Yeah, John, I agree with you. And I like the fact that we can cheat, because then we can actually build what we want to build on top of it. We're not working on the hard problems. We're working on, hey, what do we want to actually achieve? We'll see more of that next week when we get into building a sniffer in Python in order to be able to capture packets on a network and be able to display their contents and get more information about the kind of traffic that we're seeing. And we can do that where in the past, I know I was at the Pentagon a number of years ago and we were doing tests and we had to use these fancy sniffers that were hundreds of thousands of dollars in order to be able to do this. And now we can do almost the same thing with a Python script. So, we have evolved, hopefully. Any other questions or comments?
I'm sorry, I did have a question. Back on the scripts that you used in the in Wing for the client and the server.
Mm-hmm.
And it's entirely possible I just missed something. It just is kind of bugging me as I sit here and think about it. On the, which was that the starter server script,
Mm-hmm.
where you have if B exit and buffer lower. How this sound? I don't know how to phrase this. How is that able to? How was that script able to recognize the exit word? It seems like whenever we've used if loops before, we've always had to reference it in something that was defined.
Mm-hmm.
And it seems like it's able just to understand exit without it being defined in the script in any sense.
right?
I don't know
See,
if that makes sense. I'm
yep,
sorry.
no, it makes perfect sense. So in the case, when we get this buffer from that's being transmitted from the client, there could have been a whole bunch of words, within that. And all I said was, hey, if the word exit appears anywhere in what was being sent by the client, we're going to exit. And the reason that happens is that when information is transferred, at least in version 3 of Python, that data comes back as bytes, not as simple strings. So all I'm saying here is if the byte string exit exists anywhere, that's why I use the in the buffer lowercase, I get the broadest match, right? So if it's anywhere in the buffer and I'm converting the buffer to lowercase so that it matches this simple definition of exit, then the if will be true. And then we'll print out server terminated, and then we'll break out of the while loop. So basically all I'm doing is I'm looking for this keyword anywhere in what we sent. And if it's in there anywhere, it's going to exit the script. So there's just a quick way of basically allowing the client to terminate the connection that the client made to the server with a keyword.
So if somebody typed in the word like Brexit with
Yep.
BR at the front, would it still terminate?
It will. Exactly. Because that's kind of the beauty, or or not the beauty of the in operator that you can use within an if statement. So I can say if exit is in the buffer anywhere, or if some word is in a list, or if it's in a set, or if it's in a dictionary, I can basically just make that more general. You've probably seen this before when you're doing things like searching your email, and you can say, hey, if the subject line contains, right, some string, then I want to know about it. So the in operator is very similar to contains, right? So as long as the buffer contains the word exit anywhere in it, it will evaluate to true, and then it will take and execute those two lines.
Thank you.
Oh, you're welcome. You're welcome. It's always good to take a look at, things like that within the script and say, well, how did you do that? And to your point, Allison, I mean, I could have said, exit equals B : exit. And then I could have basically said if exit is in buffer. So all I'm basically doing is creating a variable with what I'm looking for, and then saying if exit, which is the variable that contains the byte codes exit is in the buffer, then we could do that. So, to answer the other question, if I wanted to be really, really specific, I wouldn't use in here. If I wanted it to be just that, and let's say just in lowercase, I would say if exit equals quote exit, right? I'm sorry, equals buffer, right? So in that case, it would say, okay, the buffer, the only thing that would be allowed to be in the buffer would be the word exit. So you can phrase it any way you want to. Let me put my script back the way it was, just in case I decide to save this. It'll still be the way it was supposed to be. So you guys know how to do that, right? I made all those changes in the script, and I'm just hitting Control-Z, and basically it'll put it back the way it was. It'll take each of the edits that I did and revert them. I'm sure you use Control-Z in other applications, not just Wing IDE. Okay. All right. Well, I'm going to give you some of your life back then. We will be holding a, oh, I think Elizabeth's on the line. Elizabeth, anything from you that came across your desk that needs addressing? I always want to thank you for everything you're doing for the group too.
I didn't receive any questions from last week's assignment, but if students do run into any problems this week with the script, they can always look at chapter 2 for Black Hat Python. It has a lot of good examples with clients and servers for this week.
Yep, that excellent. Yeah, always look at the in D2L. It'll, if there's a chapter in the book that really provides some good examples, it'll be referenced there for you, so you can go get another source and take a look at that as well as if you recall in the briefing that you also have, there is a reference to Real Python and its website that basically has some really good information that kind of dives into network sockets as well. So a couple of different places that you can go and take a look at other approaches to this as well. But yeah, thanks, Elizabeth, for mentioning the book. Okay, and then again, as always, and Elizabeth will put out a notice on this. We'll have a Python tutoring session on Saturday, and then office hours on Monday. And then next week, as I kind of alluded to, we're going to talk about penetration testing with Python and then packet sniffing with Python. So we'll be talking about those two topics next week and developing some scripts that are slightly more offensive, in nature, that will be sniffing packets and interpreting those as they run across the wire. So we're moving to that next week. And again, all written in Python with, I think, all but one standard library. We have one external library that we use in the packet sniffing area, but it's already built in the VLE for you, but it's almost 99% standard Python without any third parties. So there's nothing else. Have a good night, good rest of the week. Hope to see you on Saturday and Monday and next Wednesday. And have a good rest of the week. Take care.
Thank you.
You too.
You're welcome.